All right, ready to unlock some serious Excel power today.
Let's do it.
We're going deep on the DAX index function.
Ooh, index.
I think we both know our listeners are already pretty savvy with basic lookups in Excel, right?
For sure.
But today, we're going way beyond those basics.
Absolutely. We're going to unlock index's true potential.
We're working from this excerpt, by the way, that really gets into the nitty-gritty of how index works.
Yeah, it's a good one.
Before we get too deep into the technical stuff, though, I'm curious, when you say unlock the potential, what kind of real-world scenarios are we talking about?
Well, let's say you're analyzing sales data, right?
Yeah.
You might need to find, like, the top performer in every region.
Okay, not just the overall top seller.
Right, exactly. Or maybe you're tracking project deadlines across different teams.
I see.
And you need to figure out the latest completion date, but just within each team.
Not just the absolute last date overall.
Right. These are the kinds of problems iIndex is perfect for.
Okay, yeah, I'm starting to see the power here. So how does this, index magic actually work?
Well, it all starts with DAX, right?
Yeah, DAX, which stands for Data Analysis Expressions.
Exactly. DAX is this, it's a formula language, a really powerful one for working with data. You see it in tools like Power BI and, of course, Excel.
Good old Excel.
Yeah, exactly. And the index function is like one of DAX's most versatile tools. You know, it's all about pinpointing a position within a table and grabbing the data at that exact spot.
So it's like saying to Excel, go to this specific row and tell me what's in this specific column.
You got it. Now, the way we tell iIndex where to go and what to grab, that's all in its syntax.
Right, the syntax.
It might look kind of intimidating at first glance, but trust me, it's not that bad. The basic structure is you have index, then parentheses, and inside you put the position, a comma, then the relation, and then you've got a bunch of optional parameters that you can add to give iIndex more specific instructions.
Okay, let's break that down a bit. Position seems pretty straightforward, right? Yeah. It's the row number.
Exactly. But here's where it gets interesting. You can actually use both positive and negative numbers for the position.
Wait, what? Negative row numbers?
Yeah. Positive numbers count from the top, so 1 is the first row, 2 is the second, and so on. But negative numbers, they count from the bottom.
Okay, that's cool. So -1 would give you the last row.
You got it. -2 gives you the second to last, and so on.
So I can count backwards through my data.
Huh.
That's pretty neat, but also kind of counterintuitive. How often would you actually use that in the real world?
You know, it comes up more than you might think. Like, imagine you're tracking inventory, right? And you want to find the last item that was sold.
I see.
Using a negative position in your index formula, that'd make it super easy.
Okay, that makes sense. So we've got position telling index which row, and then we've got relation. What's that all about?
Relation is basically your data map. You know, it's the table or the range of data that you're working with. So, if you're looking at sales in a spreadsheet, the relation would be that whole sales table.
Okay, so far so good. We've got the position telling index which row to go to, and the relation telling it what table to look in.
Exactly.
But how do we actually make sure that index finds the right row? Especially when you've got tons and tons of data. I guess that's where those optional parameters come into play.
You nailed it. Those optional parameters are they give iIndex its superpower.
Superpower.
Yeah. They let you sort your data, tell it how to handle blank cells. You can even divide your data into chunks.
Interesting.
Pinpoint rows based on really specific combinations of values.
Okay, this is usually where I start to feel a little lost. But I'm ready to dive in. Which one of these optional parameters should we start with?
Let's start with order by.
Order by.
Yeah, it's super important because it controls how index actually searches through your data.
Yeah.
Think of it like organizing a bookshelf, right? You can arrange books by the author, or the title, or the genre. Order by lets you tell iIndex how to arrange the data so it can find the right row.
So if I'm looking for, say, the top-selling product, I would use order by to sort by sales amount, in descending order.
Exactly. That way, index knows to look at the highest sales figures first, and it can find the row with that top-selling product.
Awesome. Now, what about blank cells? I'm sure those can cause all sorts of problems, right?
Oh, absolutely. Blank cells can really mess things up if index isn't sure what to do with them.
Yeah.
That's where the blanks parameter comes in.
Blanks.
Yeah, it gives you 3 choices: default, first, or last.
Okay, so walk me through those options. What happens if I just leave it at the default setting?
With the default, well, Blank cells for numbers are treated differently than blank cells for text.
Oh, that makes sense.
Yeah, so for numbers, the blanks kind of end up squeezed between the 0 and the negative values.
I see.
But for text, those blank cells get placed before any other text, even before empty strings.
So I guess choosing the right option for blanks is really important because it can affect how my data is sorted and whether I get the right results.
Exactly. You don't want those blank cells messing up your analysis. Now, if you choose first, all the blanks are placed at the very beginning, no matter what type of data you have or whether you're sorting in ascending or descending order.
Okay.
And if you go with last, all the blanks go at the end.
All right. So I definitely need to think carefully about those blank cells before just using index.
Yeah.
Without thinking about it too much.
For sure. Okay. Are you ready to tackle another parameter?
Bring it on.
All right, this one's all about dividing your data into chunks so you can do more targeted analysis. It's called partition by.
Partition B. It sounds like we're really getting into some serious data manipulation here.
Oh, yeah.
All right, I'm ready. Lay it on me. What's so special about partition by?
Yeah.
Okay, partition by.
Yeah.
I like it. Sounds like we're slicing and dicing our data.
Yeah, okay.
We're ready to learn how to use this powerful knife.
Partition B is all about, it lets you split your data up into smaller pieces.
Silver chunks.
Yeah, exactly. And you do it based on the values in a specific column.
So if we go back to that sales data example, if I want to analyze sales performance by region, I could use partition by to create separate chunks for each region.
Exactly. It's like imagine your data is a cake, and partition by is like you're cutting it into slices.
Okay, I like that.
One slice for the East region, one for West, one for North. You get the idea.
Yeah, I get it.
And then you can apply index to each slice, like individually.
So I could find the top performer in each region instead of just looking at the top seller across the entire data set.
Exactly. And it's not just about finding the top or bottom values either.
Oh, okay.
Partition by lets you do all sorts of analysis on those smaller chunks of data.
Okay, my brain's working hard here.
I know, it's a lot to take in.
Let's shift gears for a sec.
Sure.
Let's imagine this function as a pizza.
Okay, pizza.
So partition by lets me cut that pizza into slices, but what if I want to pick out, I don't know, a specific topping on a specific slice?
Ooh, I see where you're going with this.
That's where match by comes in, right?
Perfect analogy. Match by adds this extra layer of precision to index. It lets you zero in on rows that have really specific combinations of values.
Within those slices or partitions that we created.
Right. So with your pizza, if you want to find the slice with pepperoni and mushrooms.
Match by helps me find that exact slice.
Exactly. Or let's go back to your customer database example, where you wanted to find the third purchase made by a customer with a specific ID, but only within the West region.
Yeah.
So partition by would first divide up the data by region, right? Creating the separate slices.
Right.
And then match by would kick in and say, okay, within the West slice, let's find the row where the customer ID matches and the purchase number is 3.
That's so cool. It's like I have a microscope zooming in on exactly the data I need.
Yeah. And being able to combine partition by and match by, it just opens up so many possibilities for, really targeted analysis.
I got to say, this deep dive is living up to its name. We're uncovering some serious Excel gems here. But I have to be honest, when we start talking about all these parameters and functions, my head starts to spin a little.
It's a lot to process.
Are there, any common pitfalls? Things to watch out for when I'm using index.
Yeah, definitely. One common mistake is trying to reference a row that doesn't even exist.
Okay, I guess that makes sense.
If you try to find the 10th row in a table that only has 5 rows, you're going to get an error.
Yeah, you can't just pull data out of thin air. Anything else I should be careful about?
Another one is when you're using index inside calculated columns.
Calculated columns.
Right.
Right, like when you want to, calculate a profit margin for each sale.
Exactly. So if you're using index within a calculated column, you absolutely need to use the order by parameter.
Okay, why is that?
Because otherwise, Excel doesn't know how to sort the data in that new column, and you're probably going to get an error.
So it's like telling Excel, hey, when you're calculating this new column, make sure you arrange the data this way so index knows where to find the right values.
You got it. It's like giving Excel those clear instructions, especially when you're dealing with calculated columns.
Okay, good to know. I'll keep that order by thing in mind.
For sure.
Now, there are a couple other parameters we haven't really talked about yet. Axis and reset. What are those all about?
Those two are a little more specialized. They're mainly used for like visual calculations, especially in tools like Power BI.
I see.
They give you really precise control over how index interacts with things like charts.
Okay. So not something I need to worry about if I'm just using regular Excel spreadsheets.
Probably not. Axis basically lets you specify which axis of the chart you're working with, like horizontal or vertical, and reset controls whether the calculations restart at different levels in a visuals hierarchy. They're powerful tools, but for most everyday Excel stuff, the other parameters are usually enough.
Okay, that's good to know.
Yeah.
But before we move on, I just want to make sure I'm clear on something. You mentioned that you can combine index with other DAX functions.
Oh, yeah, for sure.
Can you give me an example of how that works?
Absolutely. One of the most common and powerful combinations is using index with the match function. Yeah, index and match, they're like a dynamic duo when it comes to data retrieval.
A dynamic duo. I like that.
match, it helps you find a specific value in a range.
Mm-hmm.
And then index swoops in and uses that location to grab a corresponding value from another range.
Okay, I need a real-world example here.
Okay, sure.
Let's say I've got a spreadsheet with product IDs and their price is right.
Yep.
How would I use this index and match combo to find the price of a particular product?
All right, so let's say you're trying to find the price for product ID ABC123.
Okay.
You'd start by using match to find where ABC123 is in your list of product IDs.
Okay.
Match would be like, hey, I found ABC123, it's at position 5.
So match tells me where it is, and then I take that position, 5 in this case, and plug it into index.
Exactly. You'd point index to your list of prices and say, give me the value at position 5.
Okay.
Boom, index spits out the price that matches ABC123.
So it's like a dynamic lookup, right?
Totally.
Where the criteria for the price can change based on other stuff.
Yeah, and that's just the tip of the iceberg with index.
Really?
Oh, yeah, you can combine it with other DAX functions too, like calculate.
Calculate. Okay, now we're talking some serious data magic.
I know, right?
Remind me what calculate does again.
So calculate, it's all about changing the filter context for your calculations.
Okay.
Think of it like adjusting your focus, zeroing in on a specific subset of your data.
So where does index fit into all of this?
Let's say you want to figure out the average sales, but just for your top 10 performing products.
Okay.
You could start by using index with order by to figure out which rows have those top 10 products.
Right, so kind of like creating a little top 10 list.
Exactly. Then you would take that index formula and wrap it up in a calculate function.
Okay.
Calculate, hey, just calculate the average using these specific rows that index found.
So we're not just grabbing data anymore, we're actually doing calculations on very specific parts of it.
That's the power of it.
This is next level Excel stuff.
It is. And the more you explore these combinations of DAX functions, the more you can do.
Are there any other index and DAX pairings that I should know about?
Oh, there are tons, but those are a good place to start.
Okay.
My advice is just experiment, See what works for you.
That's great advice. I'm definitely feeling inspired to fire up Excel and start playing around with index.
It's a game changer for sure.
It really is. This has been an awesome deep dive into the index function.
Yeah, it's been fun.
I learned a lot more than I thought I would.
It's a powerhouse function. There's so much you can do with it.
Well, folks, it's time to unleash the power of index and take your data analysis skills to a whole new level. Thanks for joining us on this deep dive into DAX and index.